Okay, retrieval roulette. So pause, answer the questions, restart once you're ready to mark them. Okay, and here's the answers. So again, pause and get those marked and corrected, and then let's get cracking on with today. Okay, so last day we were doing questions 1 to 5 from these end of topic questions from our forces topic. The questions are a wee bit all over the place and some of them are tricky enough, so I'm just going to spend some time going through them here. So for 1A, state Newton's second law of motion. So acceleration of a body is inversely proportional to its mass, directly proportional to the resultant force, and acts in the direction of the resultant force. Now for part B, a plane accelerates from rest, so I'm listing my information here, to a velocity of 50 meters per second, so V is 50, in 25 seconds, so the time taken for that was 25 seconds, and we had to calculate the acceleration. So we've got uv and we've got t, so we'll just use a equals v minus u over t. So final velocity was 50, initial was 0, and the time taken 25. That gives us 2 meters per second, right? Part C. Okay, some of the forces acting on the plane before takeoff are shown here. So we have a thrust of, is that 60,000? Flip, that's hard to read, yeah. 60,000. The drag forces are 1,500. So we don't have...
Who do you want to send it to?
Oh, we don't have our forces balanced. Well, I suppose we know that, it's accelerator. Let me see, use your answer to part B to find the mass of the plane. So we have the acceleration, we've just been given information about the forces and we're being asked about the mass, so it's going to be F equals ma that we use here. So here's my working out for that. So F equals ma. Remember, the F in F equals ma is the resultant force. So the resultant force on this plane is going to be the thrust minus the drag. Now, it's very likely that you have read that number differently than I have because it's very poorly printed. So if you've got like 50,000 or whatever there, your answer's going to be different, but that's fine as long as your working out is the same here. So forward force minus the drag force is going to give us our resultant force, and that's equal to the mass multiplied by the acceleration, which we just figured out was 2. So 60,000 take away 1,500 gives me 58,500. Mass multiplied by 2, we just write that as 2m. Divide both sides of our equation by 2 and we get 29250 kilograms. So question 2, state Newton's first law of motion. So in the absence of external forces, a body will remain at rest, or if moving, continue to move at a constant velocity in a straight line. Part B, a fighter plane of mass 3,000 kilograms lands on the deck of an aircraft carrier. An arrestor cable exerts a force of 90,000 newtons to oppose the motion of the plane. Calculate the deceleration of the fighter plane. So F equals ma. The force was 90,000, the mass was 3,000, and then we're just dividing 90,000 by 3,000 to get the acceleration, and that gets you 30 meters per second squared. So the deceleration, 30 meters per second squared. Let me see. C, the arrestor cable brings the fighter plane to rest in 2 seconds. So you can see here, it's very, well, I shouldn't be complaining, it's very sunny. Right. So let me see, let me get this all in. The arrestor cable brings the fighter plane to rest in 2 seconds. Yeah. Calculate the velocity. Look, I've put my question mark there. Hold on a wee second. Sure, I'm in Egypt. Right, okay. So I'm going to start that one again. Where am I? The arrestor cable brings the fighter plane to rest in 2 seconds. So the time there is 2 seconds. Calculate the velocity with which the fighter plane landed. So that's going to be u, and then v is going to be 0 because it came to rest. And we've just figured out the deceleration was 30, so our acceleration is minus 30. So then we can put that into a equals v minus u over t. So the acceleration is minus 30. V is 0, u is what we're trying to get, and our time is 2. Yeah, look, I've made a mess whenever I was doing this. Multiply both sides of our equation by 2, and we end up getting minus u equals minus 60, so u equals 60 meters per second. Oh, sorry about that wee one there. So question 3A, I had asked you to leave out because we left it out whenever we were doing it. We didn't do the experiment to verify Newton's second law, so we'll have a wee look at that once we're back in school. Okay, so 3A, leave out, but the rest of 3 we were able to do. So let's have a wee look. The graph here shows how the acceleration of an off-road car depends on the force exerted by the car's engine. So we've got force along the bottom and acceleration up the side. Use the graph to calculate the mass of the car. So if we use F equals ma, then we can rearrange it and make the mass be the subject. So mass equals force divided by acceleration. Now, what have I done here? I have just picked out 1 point from the graph. So see that 3,000 and the 2? That is because a force of 3,000, if we go up until it hits the graph, has an acceleration of 2. So it's likely that you have chosen different numbers here, and that is fine. They'll always get you the same answer. So 1,500 kilograms. Now, part C. On a different journey, the velocity of the car increased from 6 to 18. And you can see here my list as I've been reading this. So U is 6 and V is 18 in a time interval of 4 seconds. So the time was 4 seconds. Calculate the acceleration of the car. So A equals V minus U over T. Substitute in our values and we end up getting, I'm trying to get my shadows, 3 meters per second squared. Okay. Right, question 4. An aircraft sits at rest on an aircraft carrier deck. They're obsessed with these, aren't they? In order to lift off successfully, it must reach a speed of 75 meters per second. The time interval between the beginning of its motion and its liftoff speed is 1.5 seconds. Calculate the acceleration. So it has to reach 75. So V is 75. It's going to be starting from rest. So U is 0 and the time is 1.5. We have to get the acceleration. So A equals V minus U over T. Substitute in your values and you end up getting 50 meters per second squared. For part B, it tells us the mass of the aircraft is 22,000 kilograms. Use that along with your answer to part A to calculate the resultant force. So now we've got the mass and the acceleration, we can use F equals ma to get the resultant force. So the mass multiplied by the acceleration gives us 1,100,000 newtons. Okay, question 5. Tim, who has a mass of 65 kilograms, and look, I've been making my list as I've been reading this, rides a bicycle of unknown mass. The resultant force of 210 newtons produces an acceleration of 2 meters per second squared. Disgraceful, right? Calculate the mass of the bicycle. So this is sneaky the way they've done this one. So we're going to end up using F equals ma. Hopefully that's obvious from our list, even though I shouldn't really have listed that. But F equals ma. Resultant force was 210. We don't know the mass of the bike. This resultant force is the force that's acting on him and the bike. So this mass is the mass of the two of them together, right? So m multiplied by, and the acceleration was 2. So that tells us that the overall mass is 105 kilograms, but this is just asking for the mass of the bike. He was 65 kilograms, so if we take that away, the bike must be 40 kilograms. Yeah, sneaky wee one, isn't it? And then B, a racing car of mass 2,500 kilograms. I've lost my place here. Accelerates from rest, so U is 0 on the starting grid. The engine exerts a force of 1.5 times 10 to the 4. Again, that's terribly printed. Calculate the acceleration of the racing car. So F equals ma. Starting from rest, we didn't even need to use, did we? Yeah, no we didn't. Anyway, F equals ma. The force 1.5 times 10 to the 4. Mass 2,500 multiplied by the acceleration. So divide both sides by 2,500 and we get 6 meters per second squared. Now again with that one, if you had read that number differently, if your working out is the same as mine, just you mark yours correct, okay? So hopefully that helped if you were stuck on those questions. If you got them right, then well done. If you got some of them right, well done. What I need you to do now is the rest of the questions. So from question 6 all the way to question 10 please there on page 207. And same as before, give me a shout if you need any help, but do try to look back through your notes to figure out. So it's a mixture of W equals mg, F equals ma, the acceleration equation, A equals v minus u over t, the whole stuff with getting the resultant force. I think that covers everything. I think there's a wee graph actually. Yeah, there's a wee graph we have to draw as well. Just sketch it on your file page. You don't have to worry about getting a bit of graph paper or anything out for that. Okay, I'll stop rambling. Give me a shout if you need any help. Bye.